Hey, what's up? Alright, so this video is about logarithms. Specifically, what logarithms are, and how you can do some simple ones in your head. Actually, it doesn't take a calculator to do logarithms if they're using certain numbers. So, alright, I'm going to begin by talking about exponents. And that's going to naturally lead us to a discussion of what logarithms are, because I think that logarithms are this mysterious thing, and I think it's a good way to explain them if you use exponents. So, think about this for a second. Alright, if I take 10 and I raise it to the third power, that equals 1,000. Doesn't it? So, a logarithm, so keep this in mind. This is an exponent. A logarithm is basically the inverse of an exponent. What it's saying is instead of 10 raised to the third power being 1,000, a logarithm is saying that if I take the log base 10 of 1,000, it's going to give me 3, because 10 to the third is 1,000. So I guess if you were going to state it concisely, the value of a logarithm is that number which you need to raise the base to in order to equal the argument. I'm going to say that one more time. The value of a logarithm is equal to the number that you have to raise the base to equal the argument. So this is the base, 1,000 is the argument. Okay, so I'm going to give an example here. Alright, I'm going to give another example. So imagine that I had this. If I had logarithm base 2 of 32, what would this equal? To answer this question, we need to think about what number does 2 need to be raised to the power of in order to be 32, right? Well, 2 to the 1 is 2. 2 to the 2 is 4. 2 cubed is 8. 2 to the 4th is 16. 2 to the 5th is 32. Oh, look, this is 32, so I know that this log base 2 of 32 equals 5. Does that make sense? I'll give another example. How about this? If I have log base 3 of 27, what does this equal? 3 to what power is 27? 3, right? Because 3 cubed is 27. So, I'm going to generalize. These are a bunch of examples, but I want to generalize this rule by writing down a little pattern. If I have log base b of a equals x, I can rewrite this logarithm as an exponential equation. What would that be? Wouldn't it be b to the x power equals a? B to the x power equals a, right? Base, the power of whatever this number is, equals the argument. And the question that a logarithm is asking you is, what does this x need to be so that when you raise b to that power, whatever it is, it equals a? That's basically it. So I just want to point out something. There's a lot more complexity with logarithms there can be when you introduce things like the natural logarithm and log properties and all these different rules and stuff, but this is more of a conceptual video. I really just wanted to give people an impression of how you can do logarithms, and so you know what they're talking about.